So here's a quick one. And we've probably talked a little bit about this already, so none of these concepts should be new, but we're going to talk a little bit about arrival and wandering. And so let's first talk a little bit about arrival. And so arrival is how do you arrive at a destination? And in a way, right, at a certain point when you're trying to get to a particular point, you don't want to just go there at a particular velocity and then once you get there, change direction. So you almost want to apply a bit of a deceleration force to other forces, to your seek force or whatever it might be, seek or pursue, right? It's probably seek actually. Pursue is always going to be kind of trying to navigate into something. But generally speaking, if you're seeking something, you want to start to kind of slow down as you get closer to it. And so the arrival, when you're really far away, you want to go as fast as you possibly can at your target. When you're still far away, you want to start to slow down. You don't want to go as fast as you possibly can. You want to kind of, predict your trajectory. And then as you're getting closer, you want to go even slower. And when you're almost there, you want to go even slower. And when you're at the target, then you want to stop. And so you can imagine, you can create a new force called the arrival force, which is essentially a deceleration of some kind when you are close to a particular target. That's one way to do it. Another way to do this is to create a kind of heuristic that as you get closer to an object, your seek reduces in magnitude. And both of these will ultimately give you the same effect. So that's arrival. The idea here is by the time you get to the object, you want to stop. We saw this in previous demos where when things were kind of going at a target, they would keep going and they'd have momentum, and so they would just then have to turn around, and they never quite arrived to where they were going. They were always sort of buzzing around a particular location, which is pretty cool, but sometimes you don't want it to be the case. Wandering, we earlier in this course we talked a lot about noise and Perlin noise and kind of random walks and that kind of thing, and wandering is like, how do you create an agent that sort of ambles? It doesn't really go in a particular place. It sort of doesn't really decide where to go. And so you want a smooth variation in movement. You don't want it to change and go all over the place. You want it to produce kind of small displacements to the direction of the velocity. This is not like this large thing. And wandering is also not picking this sort of random spot in the world every frame and then moving towards it. That'd be a random walk. You can utilize such things, but it won't look very good. And so what's really helpful here is we can kind of calculate a kind of coordinate on a unit circle, and then use that. So we can kind of figure out, okay, where are we going? And so this is a good link to understanding the wander force, but ultimately wandering, you can create a unit circle, and on that unit circle, we can effectively draw a line, and that will become our force that we then apply to our agent. And so this is kind of the process that we would do that. So we would take our agent, we would choose a particular distance, we would project a circle into that space, right? What's the radius? That's kind of a decision you have to make. And then get a random angle to determine the displacement vector. Based on that angle, then we can draw a line to that point, and that's now our wander function, our wander force. Now, you can kind of imagine, in this case, right, if you think about that distance, if the distance is 0, then we could be wandering in every direction. As the distance gets larger, then the wander force becomes more gradual. Now you may say, wait, but if it gets farther, then that vector becomes longer and has a higher magnitude. Well, keep in mind, right, that we're always probably going to be normalizing that vector and then applying to it some kind of wander weight that we would like to have. And if you still want to so there's a lot of kind of ways to utilize this. Ultimately, this just allows you to sort of create a varying angle, and the distance is sort of the parameter, the tweak of, well, how much, real displacement do you want in your path? So don't break up into groups. This is an online lecture, but take a minute right now and pause and think about how maybe you would implement this in code. Cool. Hopefully you did that. Welcome back. So the first step is we take a distance, we create a circle there, we determine what the radius and the distance are. Those are parameters that you get to choose. We then decide on what is a random angle, and this is something that you can determine using a random number generator. And then we find a spot on the circle that is the angle of that rotation, which is basically the center point using the cosine of the angle times the radius, and that is the way that we do it. The y would use the sine, the x would use the sine, not the cosine, but I think that's a typo. Anyways, then we would create a the center of the circle would be our position plus the vector to the center. So the circle center, sorry, is our position plus our plus that distance vector times our forward vector. Now, where do we want to go? Well, we have a spot and on that circle, and then now we create a seek force to that spot. And so one of the things that we kind of have to think about here is the randomness kind of have an effect, a pretty big effect on the movement of the vehicle, right? So if we randomize it too aggressively, we will ultimately result in a kind of relatively straight path, but with a bit of wiggle and a bit of abruption. So if you do want it to be a little bit more gradual, not super random, and you can, instead of doing a true random number generator each time, you don't necessarily want to create a new random variable each time and a random angle. You would want to create a random displacement across. So say I can choose a random start angle, say that's my start, say it's 5 degrees, then I run a random number generator times, say the maximum change I want is like 20 degrees, and then so each time I'm going to add or subtract based on the random number times 20, which is my maximum, and now I'm going to sort of randomly move this thing around. So you'll have a more gradual movement versus each time it's going to go this way, this way, this way, this way, this way. It's going to be like more like da 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 da, right? And eventually kind of represent the entire thing. That's one way to do it. Another thing is to use a Perlin noise lookup instead, and that will also work, which will allow you to interpolate between kind of a more smooth distribution. I guess that's it. Cool. Very fun. So that's about it for this week's lectures. I'm going to pop open a demo and try to kind of examine some of these ideas in a minute. All right, see you then.